Hello, geometry. Welcome to Unit 9 officially. So I know we did a radical lesson yesterday, but now we're going to start actually doing Unit 9. Special right triangles is the title of this lesson, and it has nothing to do with area, and the unit is called area, but we use this a ton in the area unit and future units as well. So we'll just dive right in. Special right triangles, there are two types. Front page deals with one of them, and we'll go ahead and get started on that right now. It says draw a right triangle with a 45-degree angle. So right triangle has a right angle, and then one of the other angles is 45 degrees. Right? What is the measure of the other angle? Well, it's also got to be 45 degrees, right? 180 minus 90 minus 45 leaves me with 45. Now, besides a right triangle, what type of triangle is this? Well, if it's a right, we know it's a right triangle based on its angles, but what about by its sides? Well, you might say we don't know anything about the sides, but in fact, we do. I will tell you that this is an isosceles triangle. How do we know it's an isosceles triangle? I'm going to tell you the theorem and then I'll explain it. It's the converse, and you learned this in first semester, of the isosceles triangle theorem. Now, what does that say? That says that if two angles are congruent, then the sides across from them are congruent. So I have two congruent angles, 45 and 45. That means the sides across from them are equal. And then we don't know what they are, so I'm going to call them x. I'm just going to go ahead and do that real quick. One thing, a little relationship I do want you to see. On your calculator, type the tangent of 45. What do you get? Give you a second to actually do that. When you do that, you should get 1. Why? Well, the tangent ratio of an angle is opposite over adjacent. You should remember that from the first unit we did. Okay. So in this case, the triangle we drew, since both legs are congruent, even if we don't know what they are, we can say the ratio is x over x. No matter what x is, a number divided by itself is going to reduce to 1. That is why the tangent of 45 is always 1. Okay, that relationship, we might use that later on. So use the Pythagorean theorem now to find the length of the hypotenuse. And the hypotenuse is here in this triangle. Go ahead and switch colors, a lot of red going on. So Pythagorean theorem says that x squared plus x squared equals h squared. Well, x squared plus x squared is 2x squared. If I'm going to get h by itself, I'm going to take the square root of both sides. And I can split that up. So I'm going to do the square root of 2 times the square root of x squared gives me h. What can I reduce there or simplify? Square root of 2. The radical and the squared cancel, and I'm left with just x. And that equals the hypotenuse. So the conclusion, and notice this is in bold, this is very important. The conclusion we can draw from everything I've just done is that the length of the hypotenuse, h, is equal to the square root of 2 times the length of the leg. The length of the leg was x. It's always times square root of 2. That relationship happens in every 45, 45, 90 triangle. Because of that, we can now find side lengths much quicker in these situations. All right. And we're going to go to the bottom here and do a couple practice problems with that. The first one is pretty straightforward and basic. The second one's a little harder. So the length of the leg, the length of each side of the triangle, I gave you AB was 8. You want to find BT and AT. So I'll call BTX and ATY. Now, before you do anything, you want to look at your angles. I have a lot of people who assume we have a 45, 45, 90, when in fact we don't. If we have a 45, 45, 90, great. But if we don't, you cannot apply these properties or these relationships. We do have a 45, 45, 90 here, so we can. In a 45, 45, 90, the legs are congruent. So AB is congruent to BT. So x equals 8. The hypotenuse is equal to, right? We just figured this out, the conclusion up there, The hypotenuse is equal to the square root of 2 times the leg, and the leg was x. So the hypotenuse is equal to the square root of 2 times 8, and we write that as 8 radical 2. Okay. On the next one, a little trickier because in this one, I did not give you a leg. I gave you the hypotenuse. Call this x and call this y. We're looking for those two sides. Good news is we know that those are equal because it's a 45, 45, 90. Right? So let's go ahead and find it. I'm going to use that same equation. Notice I start with the same equation here. H equals the square root of 2 times the leg. And I'll just use x for our leg, even though I know x and y are equal. And now I'm going to plug in what I know. I know 10 is the hypotenuse. I'm going to put that in for h. Now I got to get x by itself. I'm going to do the square root of 2, divide by the square root of 2, which is great. I got x equals 10 over the square root of 2. Simple, right? However, I can't leave my answer like that because I can't have a radical in the denominator. So what am I going to do? I'm going to multiply top and bottom by the square root of 2, like I showed you in the radical video. And you're going to get 10 radical 2 over 2, and then the 10 and the 2 reduce, and I get 5 radical 2. So x is 5 radical 2, and so is y, because the legs are equal. All right, so that's a 45, 45, 90. There is only one relationship that you need to see. Okay. In the next one, there are 2, which makes it a little trickier, but not a lot. All right. So in the triangle below, which, by the way, the 30, 60, 90 is the next special right triangle. Label the shortest side S. Well, this looks like the shortest side. I'm going to put an S there. Can I conclude that it's the shortest side without any question? Yes, I can. Remember in first semester, the shortest side is across from the smallest angle. Well, I've got my 30 degree there. I can figure out angle C by doing 180 minus 90 minus 30, and I get that that's 60. 30 is smaller than 60. Therefore, BC is the shortest side. Now I'm going to make a second triangle so that triangle ACB is congruent to triangle ADB. Now, what are you're like, what am I doing here? What am I talking about? I'm drawing a mirror image like that. Okay, and I'm gonna call this D. And I'm telling you that those two triangles are congruent. That's given. Okay, so think of it as given. Because I set it up, I can make that true. I'm now going to prove, not completely prove, but I'm going to prove the two relationships in a 30, 60, 90 triangle. All right. Because the triangles are congruent, I can use CP, right? And what that says that's going to help me here is that DB is congruent to CB, right? So I could call this S over here. Now, I can go a little bit further and I can say triangle ADC, the full triangle, is equiangular. Because if this is 60, right, it equals angle C, then the remaining angle, that whole angle up here, is also 60. But if it's equiangular, so it's also equilateral. So all the sides are the same. Well, if it's equilateral and DC equals 2S, right? DC from D to C is S plus S, which is 2S. Then AC is also 2S. And there is your first relationship. Okay, and let me spell out what I just said there. The short leg, if I multiply it by 2, I will get the hypotenuse, right? 2S is the hypotenuse here. Okay, the length of the hypotenuse is 2 times the length of the shorter side or the shorter leg. All right. That is the first relationship that I want you to see. Okay. The second one is the long leg, which is right here. All right. I'm going to use Pythagorean theorem to do this one. So I'm going to do s squared plus x squared equals the hypotenuse squared. Well, s squared is just s squared. X squared is just x squared. 2s times 2s is 4s squared. I'm going to subtract s squared from both sides. I get x squared equals 3s squared. Square root of both sides, I get x equals the square root of 3 times s. And right there is my next relationship. X is the long leg. It's equal to the square root of 3 times the short leg. And those two relationships work in every single 30, 60, 90 triangle. Okay, so I'm going to summarize that after I clear this. Scroll down here. Two conclusions. I already wrote one, but I'll write it again. The length of the hypotenuse is 2 times the length of the short side. And the length of the longer side is the square root of 3 times the length of the shorter side. Now, hopefully you notice that the short side is nice and is important to know. When you know the short side, the rest of it's pretty easy. So three examples here, each one giving you something different. The first one, I'm giving you the short side. That's the easiest situation. Why? Well, because the long leg, which is B, and the hypotenuse, I don't really have to do any dividing. It's all multiplying. So I'll do the hypotenuse first, since that one's usually easier. So the hypotenuse is equal to 2 times the short leg. And the short leg here in this case is 5, so 2 times 5 is 10. The long leg is equal to the square root of 3 times the short leg. So that's just 5 radical 3. Done. What happens if I give you the long leg? Usually this one's actually the hardest. Well, if I give you the long leg, I have to start with conclusion number 2. Conclusion number 2 is the only one that involves the long leg. So I need to start there. So the long leg equals the square root of 3 times the short leg. And the short leg here is x. Hopefully you see it. It's always across from the 30-degree angle. If this is the 60, this is the 30. So the short leg is x. Well, I know the long leg is 12. I'm going to divide by the square root of 3, and we have, again, a radical on the denominator. Multiply top and bottom by radical 3. I'm going to get 12 radical 3 over 3, which reduces to 4 radical 3. So the short leg is 4 radical 3. Hopefully you realize that once you have that short leg, the hypotenuse should be pretty easy. So the hypotenuse is equal to 2 times the short leg, which is 4 radical 3. We just found that. So 2 times 4 is 8 radical 3. All right. Last one, if I get, first example was short leg, second example was long leg. You can probably guess what the last one's going to be. I'm going to give you the hypotenuse. If I give you the hypotenuse, which conclusion do you need to start with? It's got to be conclusion number 1. The hypotenuse is equal to 2 times the short leg, and the short leg in this problem is, again, x. Hypotenuse is 16. Divide by 2, you get x equals 8. Now I can do the second conclusion, and the long leg is equal to the square root of 3 times the short leg, which is 8. Just found it. So 8 radical 3 is my long leg. Okay. We're going to spend a couple days on this because it is that important that you understand these relationships and you can use them accurately. All right. So that's it for this video. And we'll, like I said, practice in class.